My name is Talia. I'm a high school senior and I love teaching others about chemistry and math. This YouTube channel is an extra resource for anyone who may be needing some help in their chemistry classes. This week, I'm going to be starting my unit on solutions and beginning by talking about calculating concentration in standard solutions. So if you need some help with those two topics, feel free to keep on watching. Without further ado, let's get started. Okay, so before we begin this unit, I'm just going to go over some common terms that have to do with solutions. And they will be popping up a lot in this unit, and I will be talking about them a lot in this unit as well. So first we have a solution. And if you remember back to the beginning of my videos, when I talked about homogeneous mixtures, heterogeneous mixtures, stuff like that, a solution is a homogeneous mixture because it contains two or more substances and it has a uniform appearance. In a solution, there is a solute and a solvent. A solute is what is dissolved, and a solvent is what does the dissolving. So for instance, in a solution of salt water, the salt is the solute and the water is the solvent. Finally, and we are going to be working with this term a lot today, is concentration, which is the amount of solute in a given amount of solutions. And in chemistry, this can be also called the molarity. So we are going to calculate that in this video. So solution concentration can be calculated with three different equations, and these are just like the density equations where each equation you can manipulate to get the other one. So the main one that we would be using to calculate concentration is C equals N over V. That can also be manipulated to get N equals CV and V equals N over C. So the C in these equations represents concentration, which is represented by a capital M in units, and that M is molar concentration. N represents moles, which is the moles of solute, and V represents volume, which is in units of liters. So M is definitely a new variable, and molar concentration is calculated by moles over liter, which you can see in the C equals N over V equation because we have the moles divided by the liters. And conceptually, this does make sense because concentration is defined by the amount of solute in a given solution. So the amount of moles of something given within the volume of the whole solution. So now we're going to do a practice problem. What is the volume of an 0.046 molar concentration solution that contains 0.13 mole HCl? So I have my concentration and I have my moles and I want to calculate volume. So I'm going to use the V equals N over C equation. You could use C equals N over V. It would just take a little bit more time. In this equation, I'm solving for volume, so I'm going to rewrite it to solve for volume. And then I am just going to plug in what I know. So I have 0.064 over 0.13 moles.
Hi, this is future Talia editing. I fully realized that I wrote 0.064 instead of 0.046, so just pretend the directions in the problem did not say 0.046 and continue the problem as if it was a concentration of 0.064 molarity.
Then I'm just going to plug that into my calculator. Get 0.49 liters. And these units do cancel out because remember, molar concentration is moles over liter, and we're dividing by moles, which means we're multiplying by 1 over mole. Moles cancel out, and we're just left with liters. So that is our answer for the first question. Now we want to figure out how many grams of CaO2 does 700 milliliters of 2.30 molarity solution contain? How many molecules are present? Before we begin, just another thing when you're writing concentration, if you want to write like the concentration of CaO2 equals 2.30 molarity, you would write it like this with brackets, just an official thing you'll have to use in a lot of your problems. Okay, so we have our volume that we're going to need to convert, and we have our concentration, and we want to get grams, but we're going to need moles to do that. We also need to get molecules. So let's first convert our volume. So 700 milliliters times 1 liter over 1,000 milliliters equals 0.700 liters. Okay, now let's find our moles. So N equals CV, so it equals 2.30 times 0.700, and that equals 1.61 moles CaO2. Now we want to calculate mass. So I am going to do 1.61 mole CaO2, and we know how to do this step. I'm just going to multiply by molar mass, but I first need to figure that out. So the molar mass is 40.08 plus 2 times 16 is 72.08 grams per mole. And we are going to get 116 grams of CaO2. Now we want to calculate how many molecules are present. So we're going to use these same moles and do an Avogadro conversion. So we have 6.02 times 10 to the 23rd molecules over 1 mole CaO2. So now I'm just going to multiply 1.61 by 6.02 times 10 to the 23rd, and we are going to get 9.69 times 10 to the 23rd molecules CaO2. And that is this problem. Okay, so now we are going to move on to standard solutions. And standard solutions just have a known concentration, and we're mainly going to be discussing them in terms of how to prepare them. So they can be prepared by determining how much mass of the solute you need and mixing it with water to get the correct total volume. So with these problems, you'll usually be given a volume and a concentration, and you have to figure out the mass of the solute and describe the process. Standard solutions are made in volumetric flasks. So we are going to do an example. So we have 150 milliliters of an 0.30 molar solution of AlNO3. I'm actually first going to convert my volume. So 150 milliliters equals 0.150 liters. Okay, so let's calculate our moles. So I'm going to do our concentration times our volume. Then we'll get 0.450 moles AlNO3. Now we want to convert that to mass. So just a reminder, we are describing how to prepare this solution, and you can't just like pour in certain volume of a concentration. The way you make these solutions is by dissolving a solute in a solvent. That is what a solution is. So we need the solute, and that's what we're trying to find. So we are going to do the molar mass, which is 26.98 plus 3 times 14.01 plus 9 times 16, which is going to get me 213.01 grams over 1 mole. And then I'm just going to multiply the number of moles I got by the molar mass. And that is going to give me a mass of 95.9 grams AlNO3. Okay, so now we have our mass. So now let's write out our steps. So our first step is going to be to weigh 95.9 grams of AlNO3. So now we need to figure out how much water we are going to dissolve our aluminum nitrate in. We do not want to dissolve it in 150 milliliters of water because 150 milliliters is the volume of the solution we want. And if we dissolve it in 150 milliliters of water, we could end up with more than 150 milliliters of solution. So we're going to want to dissolve it in less than 150 milliliters of water and then pour in more and more water to get to our desired volume. So my step 2 is going to be to dissolve in, and I'm going to choose 75. Actually, we'll make it a round number. Let's do 80 milliliters of water. And then I'm going to transfer my solution to a volumetric flask because it was previously like in a beaker or something else. Transfer to volumetric flask and add water to total volume. And so those are to total volume of 150 milliliters. I'm going to just write of solution so that it's clear. And your steps don't have to be exactly like this, word for word. This is just how I'm choosing to explain it, but you want to get the same idea across that you are going to want to calculate the mass of solvent and then dissolve it in less than the desired amount of volume of solution, and then add water to get to your desired volume of solution. So that is how you prepare standard solutions. They have a known concentration. That's why they're different than just a regular solution. So that is the end of our first video. So that concludes this week's video. Next week, I'm going to be talking about solution dilution and also doing a quick little mention about spectrophotometry. So feel free to join me back next week if you would like to learn more about those topics. As always, you can leave any questions or comments you have in the comment section below, and I will do my best to answer them. I hope you enjoyed, and good luck with learning the rest of your chemistry.